Hello students, welcome to the next lecture on the PY questions. Today we will discuss about Bayes Estimator. One question definitely asked in the CSIR NET examination related to this 4.75 and one question related to the 3 marks. So total 7.5 will be there, and I will explain you with the help of the shortcut tricks. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the various PY questions and the topic wise. Also, you can scan and join my WhatsApp group. What you can find in my playlist, there is a playlist of the PY questions of the CSIR NET and GATE mathematics, and you can see there is a complete topic wise solution, and you can see all those from the GATE and the CSIR NET examples we have covered in this playlist. There is one more playlist known as the CSIR UGC NET and GATE, where you can find the topic wise and the year wise solutions of the each question papers, like real analysis June 17, June 18, statistics solutions as well in this playlist. So you can follow this one and then you can learn many new things. So what is the objective of this lecture? We will see all those questions from the Bayes Estimator related to these last 13 years. We are explaining the 30 plus questions which was asked in here with the help of the shortcut trick. So before I give you the solutions of these examples, let me firstly recall what is the Bayes Estimator and what are the various shortcut trick. So whenever you are seeing the question related to the Bayes Estimator, you always try to identify from the statement about the given informations and what are the unknown parameters. These are my unknown parameters. Based on these informations and the unknown parameter, you can define the probability density function, like check whether is it follow the binomial distribution, whether it's a normal distribution, whether it's an exponential distribution. Accordingly you can define its PDF, and because it consists of more than one information, you can define the likelihood functions corresponding to them, like y is here probability. If I consider this is my y, so yi over this parameter theta. There is one more term called as the prior information, because this is my unknown parameter. So what is the prior information? So what is the distribution they have written? Once you can find all this given information, then you can start the Bayes Estimator with a very simple trick. What you can do, you can simply multiply the likelihood and the prior probability and call as the posterior probability. Remember, when you multiply these two equations, these two expressions, you only consider all those terms which involves the parameter theta. You can only return the term which involves this. Like if I say my term is 1 over 2 pi, this is a constant and it does not involve the parameter theta, so there is no need to consider this one into here, so that your calculation will be very less. Once you can define the posterior probability, then you can find the posterior mean by using here. But how you can find the posterior mean? That's as here you can find this of here over the respect of theta. Once you can solve this, you will get the posterior mean. But there are generally three kind of the questions asked in the Bayes Estimator. One is check whether what is the conjugate prior, find the posterior mean under this scared loss error and the absolute loss error. What is the meaning of the conjugate prior? You can find the posterior if I say the prior will follow the exponential distribution, for example, and if the posterior will come also the exponential distribution, then you can say these are the conjugate prior. That means if the distribution of the prior is same as that of the posterior, then we can say this is my conjugate prior. That means this prior is called as conjugate prior. How you can find the scared error loss function? You can identify the distribution of the posterior. Once you can identify the distribution, then under the scared loss error it is always with a mean, while under the absolute loss error you always try to find the median. Another shortcut trick is what is the proper and the improper prior. So if you have the prior distribution denoted as a pi, if you integrate this pi over here over this theta, range of theta, and either it come to be 1 or infinity. If it is come to be 1, then we call as the prior probability. It is improper when we call as the infinity. Remember that when you have the improper prior, then we may still get the Bayes estimate. We will see in the couple of examples. So let's start with this beautiful shortcut twist. So remember, first thing is you have to find this probability. Start with this statement. The Bayes estimation problem of the prior mean Poisson distribution with the mean is lambda. If I consider this is my x, is my posterior with my of this, fine. Since this is the x factorial here, then and the prior is my gamma, so I denote it as the prior is pi, which is gamma distribution here. Now you can check how many sample size is given to you. This is the n, so you can define the likelihood function. So what is the likelihood function? Is f of xi. Now what is that? This is a product. If you take the product of this, it will be e raised to power n into times lambda, lambda raised to power x factorial divided by product of x factorial. Fine, that is the meaning of this. Now this is the given information. Now rest of the part is very simple. You can define the posterior. How you can define the posterior? That is a multiplication of prior and this, and then you can, the unknown parameter is lambda. You can consider only the term which involves the parameter lambda. If you multiply them, it will be my beta plus n of this. If you multiply them, it will be alpha plus root summation of xi minus 1. There is no need to write the denominator because it does not involve the parameter lambda. So I consider this as a proportional. Now can you identify which distribution is here? Yes, this is my gamma distribution. You can see, if I say this is my x e raised to power minus lambda of x, then it follows my gamma distribution with the parameter x plus 1 and of here. Fine, sorry, this is, if already I taken as x, so if I consider this is my alpha, then it will be alpha plus 1 and lambda. So here will be this divided by comma of this. Fine, this is my gamma distribution. Now you can check about the options. That's over. Now your right answer will be here. You can see the posterior distribution is a gamma distribution, correct. Posterior distribution is the Poisson distribution, cancel. You have to find the mean and the variance, mean and the mean. So if x follows the gamma distribution with the parameter alpha comma beta, what is the mean? Mean is alpha over beta. So what is the mean of this? Alpha plus summation of xi divided by here. Now you can see, and I can take this summation of xi is nothing but my n into x bar plus of alpha into this. So you can see this is the right answer, this is cancel. So A and C are the right answer. Remember, this is a first example, so I recall that you always write the prior. This is my prior. You always find the likelihood if this is size of n. If it is not, then this is itself the likelihood. You can multiply them and take all those unknown parameters, and then you can find the distribution. See here, x follows the Poisson distribution. So what is that? What is this? Is e raised to power minus parameter raised to power x over x factorial. Basically this is unknown here. The prior distribution is denoted pi, is the median exponential distribution. So what is the exponential distribution? Median. Median is log of e over, this is my here. Now the median is given to be this. What is the meaning of that? This is my exponential distribution with parameter 1. So I can say this is my exponential distribution with the parameter 1 is e raised to power. You can see this is my prior exponential distribution. Now this parameter is followed theta, so I can replace x to be the theta and lambda to be 1 of here. Fine. Now you can get what is the sample size? It is not given to you, so that's a one sample. Now you can define the posterior. You can simply multiply them and consist of only terms which involves the theta. So x factorial is no need. So this is e raised to power minus 2 theta, theta raised to power x. Fine. Now which distribution is here? Again it follows the gamma distribution with the parameter x plus 1 and e raised to power, that's a 2. Fine. Then the posterior is a gamma. Fine. Prior is a conjugate prior. When it will be the conjugate? When prior is same also the gamma. So what is that? Prior is follows my exponential distribution with the parameter. What is the parameter? Is 1. So we all know exponential 1 is also called as the gamma of 1 comma 1. You can see posterior is also gamma, prior is also gamma, so this is also true. What is the mean? Now you can see it is a loss function is squared error. So once is a squared error, as I told you in the earlier tips, it is always with a mean. So what is the mean of the gamma distribution? Alpha over beta. So you can see this is my here, this is cancel out. So right answers are A, B and D are my correct answers. You can see within a couple of seconds you can get your answers. Again here, x1 and x2 are the IID with the exponential distribution. So x1 follows exponential distribution. Since mean is 1 by theta, so the parameter is my here. x2 is my exponential distribution with the parameter theta. Fine. So and they are IID as well as independent. So can you find the joint density function of this, which is nothing but f of x1, f of x2. So it has exponential this, so it will be theta e raised to power minus x1 into this for the first, theta times x2 of this. So what is that? It is my theta square e raised to power minus theta of here. Fine. What is the prior is? Prior distribution, that is a pi, is again exponential distribution with the mean is 1. So I can consider this is e raised to power here, mean is 1. So now you can define the likelihood function, consists of only term which involves theta. It is here e raised to power this x1 plus x2 plus 1. Which distribution it follows? This is my gamma distribution. Fine. This is my n plus 1 and this is x1 plus x2 plus 1. Now you need to be the absolute loss error. That means this you have to find the mean. What is the mean of the gamma distribution? Alpha over beta. So what is the right answer? C is my correct answer. Always follow the same rule for the each problem. Look at this one. Xi's are my IID with the Bernoulli. So what is that? So can you find this one? What is the distribution of the Bernoulli's? Theta 1 minus theta of 1 minus x. Now it has the n number of elements. You can find the likelihood, that is the product of xi's. So what is that? This is nothing but theta raised to power, sorry, it is a x. Fine. So Bernoulli distribution is here, then it will be theta raised to power xi 1 minus theta of n minus xi. Fine. What is the prior is given to you? Prior is given to be here, so I can return this number as theta raised to power minus half 1 minus theta raised to power minus half. Then we can define the posterior probability. I can multiply them. It will be summation of xi minus half 1 minus theta of n minus summation xi minus half. Which distribution it follows? Can you find that? Yes, it is nothing but my beta distribution of the parameter xi. What is the beta distribution? If I say this is my x, 1 minus theta of say 1 minus x, fine, then it follows the beta distribution when it will be x plus 1 and it will be this plus 1, this plus 1. So what if I say this is the x and this is y, then it's a y plus 1. So if I take this is my half, if I take this is, it will be my plus half. Fine. Now you can see the posterior mean of this does not exist. So what is the mean of this? If x follows my beta distribution of alpha comma beta, then what is the mean of the beta distribution? Alpha over alpha plus beta. So you can see it will be this alpha divided by sum. So it will be n plus 1. So the posterior mean does not exist, cancel out its existence. Fine. Now the posterior mean of that theta exists, fine, and it is larger than the MLE of all the values of the s. So basically this is my s, then your target is to prove it will be greater than of the MLE of the s. So what is the MLE of the s? S is nothing but the sum. So how you can find the sum of this? So this is nothing but my n of theta, because what is the mean of this? This is a binomial, because sum of the xi's follows my binomial, and what is the binomial mean is n into p. P is my probability, so it is my n into theta. Fine. Oh, I can return this n into theta, that's in terms of the s. How you can find this is the value of the theta, so I can return this term as s by n. Now you can see I can open this bracket, ns plus n over 2 is greater than Sn plus, so you can see S must be less than of n by 2. S means sum of the xi's must be less than of that 2. So it is it for all n? No, because there is a restriction on the n. It is 2 for some n, that's 2. The right answer is B and D are my correct options. Okay, look at this one. Suppose x is given to be here, sample size of n. So you can find the likelihood of this. So because 2 is a constant, I can skip that. So lambda raised to power n. X is again a constant because with respect to unknown parameter is lambda. So firstly I can return f is just proportional to lambda e raised to power of this. Then you can find the likelihood. This is lambda raised to power n and sum of xi square. Fine. What is the prior? Prior is given to be the exponential distribution with the mean is 1. So it's a 1 e raised to power minus of this. Then you can find the posterior. So you can multiply them. It will be lambda raised to power n, minus is common. It is xi square plus 1. Do you identify which distribution it follows? It again follows the gamma distribution with the parameter n plus 1 and it will is xi square plus 1. Fine. Then the posterior distribution is an exponential distribution. That's wrong because it's a gamma distribution. Bayes estimator of lambda with respect to the squared error mean, that is called as the mean. So can you find the mean of this? Mean is n plus 1 over summation xi square plus 1. So that's the exist and it's a unique. Is the absolute loss error. What is the meaning of the absolute loss error is? It is a median. So can you find this? Because what is the median of this? Can you find the median of the gamma distribution? Can you find its existence? Okay, firstly I can check about this. Because this is the mean of this parameter lambda, since it existence e raised to power minus lambda also existence. Otherwise I will look about the third part. So I can take e raised to power minus lambda into the posterior mean. So you can see here. Fine. Again you can see it follows the gamma distribution because I can take this pair as a common. So it is n plus 1 summation xi square plus of 2. Again it exists but he said does not exist. It's a cancel out. What is the median of the gamma distribution? Always exists. For this case it means it is a unique one. So that's a simple way you can solve. Moreover, you may remember that the median of the gamma distribution is not expressed in the closed form. Fine, but it means there is existence of that but not in the closed form. Okay, look at this another one. If y is given to be the Poisson distribution, so what is that? Is e raised to power minus lambda raised to power x. Here x is in terms of y, so y factorial. Since the denominator is independent of theta, we can skip that. Tau is a prior distribution, is e raised to power alpha into this, theta raised to power beta minus 1. So size is my 1. So you can see the posterior. Posterior is e raised to power minus alpha plus 1 of theta and theta of y plus minus 1. There is no need to write the denominator because it is independent of theta. Which distribution is follows? Again it follows the gamma distribution with the parameter this plus 1 here and alpha plus 1. The posterior distribution of theta is a gamma, that's correct. Gamma is a conjugate priors. What is that? Pi is? It is my, which distribution is there? It is also the gamma distribution. Fine. Posterior is also gamma distribution. It is, means it is a prior, correct. What is the meaning of the scared loss error? You have to find the mean. What is the mean of the gamma distribution? Alpha, there is the first term divided by second term. So you can see this is also the correct answer. Marginal distribution, hypergeometric is my discrete distribution. What is the meaning of the marginal distribution? You have to integrate this into here with respect to theta. And what is the limit of that theta? You can see this, the alpha and beta are greater than 0. Theta is my 0 to infinity, and definitely it is not a hypergeometric. Hypergeometric is your discrete distribution, but here is a continuous one. So the right answers are only B, C and D. Okay, look at this one. Xi's are my normal distributions with the mean is here, 1 by gamma square is here. You have to find all those posterior and here improper this one. Okay, for the easy calculation I can take this number is lambda, fine, so that I can return this one. So xi follows my normal distribution with the parameter 0 and here, fine. Prior distribution is my 1 over lambda raised to power alpha. So firstly we can define this probability, fine. What is that? It's a 1 over root 2 is a, you can see 1 over root pi sigma. Sigma is my 1 by root here, e raised to power minus half sigma square is upside, x minus 0 square, because you all knows what is the PDF of the exponential distribution here. So what is the sigma? In this case sigma square is my 1 by lambda, so sigma is my 1 by root of this. Now since this part is my constant, I can skip that. So basically it is my here e raised to power minus of x square. Then we can define the likelihood. What is the likelihood is n. This is e raised to power here of xi square. What is the prior is? Prior is written as lambda raised to power minus alpha. Then you can find the posterior. I can multiply them. It will be n over 2 minus alpha e raised to power minus alpha over 2 summation xi square. Which distribution it follows? Again it follows the gamma distribution with the parameter n by 2 plus 1, and what is that? This is summation xi square divided by 2. Now look at the option. The prior distribution is improper. How you can check the improper? As I told you, improper means if you integrate them, it must be infinitely. So what is the prior distribution? Lambda raised to power minus alpha. It means if you integrate them, it must be infinite. So you can check about that. It is 1 minus alpha over 1 minus alpha. This will goes to the infinity only when alpha is my 1. Fine. So you can see prior distribution is improper for all the alpha. It is not correct. It is only when it is 1. The posterior distribution is a proper distribution for all the base. Okay, fine. That we will see under the square error laws. That's a mean. What is the mean of this? N by 2 minus alpha plus 1 divided by summation xi square by 2. But here plus 1 is missing. So this is cancelled out. Posterior distribution is a proper distribution when alpha is 1. What is the meaning of the proper is? When integration is 1. So you can see proper distribution is your n by 2 minus alpha plus 1. When alpha is 1, this value will be your n by 2 and here. Fine. Then what is the value of this? Sorry, this value. What is the value when alpha is 1? So this value is nothing but n over 2 minus 1 e raised to power minus of this. Fine. Now if you integrate from 0 to infinity, what will happen? This is itself a gamma distribution. If I multiply this by gamma of n, fine, and divided by gamma by 2 here, and this is summation xi over 2 raised to power n by 2, and this, because this is a constant, so this value will definitely be a 1. So this value will be 1 only when alpha is my 1, otherwise it will not be there. So the right answer is only my D is the right answer. No, sorry, this is also the right answer for all alpha. Is it true? Is for all alpha? Because you can see this integration will be goes to the infinite when alpha will be 1, but he said for all alpha, so it means that is not the correct option. Okay, now look at this one. What is given to you? Xi's are follows the normal distribution with the mean mu and 2. Prior is also follows the normal distribution with the mean 2 and here. Then the following options are there. Very simple. I can tell you the simplest shortcut way. Whenever Xi's follows the normal distribution, prior also follows the normal distribution, then the posterior also follows the normal distribution always. Fine. Then if it is a normal distribution, then what will be the mean and the variance? So what you can do, because it consists of the sample, you can find the sample mean. We all know the sample mean is my this one. Fine. Then you can find the posterior mean, which is nothing but the weighted average of this, which is the, you can see the tau square divided by the sum of this, that's the sum of the variance, multiplied by the mean of the x bar, plus this divided by the, that's a weight, you can see this is the weighted sum into mu of p. What is the variance of this? Variance is nothing but my this factor into my tau square. So based on this we can solve this example. So you can see xi follows my normal distribution with the mean is here, prior is my follows the normal distribution with the mean is 0,half. So can you find the sample mean? Sample mean is follows my normal distribution with sigma square n. How many sample size is? 4. Fine. Then it is also follows the posterior. So with the mean is, what is the mean is? You can see the mean of the posterior is weighted average of this. So I can say this is also mu and half. So you can see the first number divided by the weighted average into this part mu, plus this number divided by the weighted average of this part 0. You can see the below is the posterior average of here. So what is that? This is 1. It is my mu divided by 2. So it has the mean is mu divided by 2. Now the prior is not a conjugate prior. When it will be the not, when the prior is a normal, posterior is a normal, so this is a conjugate, but he said no, cancel. Then once is a normal, we all know in the normal distribution mean, median and mode all are same. So what is the mean of this? Mean is my mu over 2. What is the mu? Mu is the sample mean, xi by n. So what is that? What is the n is? 4. So if I substitute here, it is 4 by, that is a 8. So the mode is nothing but the mean, correct? Median is also 8, but it is cancelled. Variance, there is no relation between them. You can see what is the variance is. You can again apply of here. So you can see it's a tau square of this. So the weightage average of this is again 1 plus here. And what is the tau is? Posterior variance. Posterior variance is my half. So you can see it will be my 1 over 4. But he said summation xi. So that means this is not the correct answer. So right answer is only my B is the correct answer. Okay, so what is that? Xi follows normal distribution with here theta is a prior distribution, that is a prior is denoted pi is also the normal distribution. So that's again same shortcut trick. I can start with here. What is that? This is 1 divided by n. How many n is here? Then the Bayes estimator of theta, that is a weighted average of this, sigma square over sigma square plus 1 over n into theta plus plus 1 over n, that is this divided by weighted average into 0. So what is that? It is, if I take the LCM, it is n sigma square theta divided by 1 plus n sigma square. Now you can check your option. Now you have to return in terms of the xi. So what is that? Theta is sample mean. Sample mean is xi divided by n. So what is that? And I can substitute here n theta is summation xi. So I can say this number is my x bar. So the numerator part is summation x bar over 1 plus n here. So what is the right answer? Where is the n? There is something wrong. This is sigma square by n. It's a 1 plus, oh sorry, this is not there. None of this is the right answer, but you can check the calculation. Is it right? N, what is that? It is xi divided by n, fine. So I can substitute the value of theta is there. So none of this is the right answer because this is n is there. So none of this is the right answer. Okay, again xi follows the normal distribution with the mean theta, variance is sigma square. Prior distribution is also the normal distribution with the mean is mu and it's a tau square. So from here I can find the sample mean, which is sigma and sigma square by n. So then which of the following statement is correct? So posterior is also follows the normal distribution, and what is the meaning of the squared loss error? It is a mean. So Bayes estimate is the mean, correct? And it's a normal. What is the meaning of the normal? Mean, median and mode all are same. Under the squared loss error, it is always the mean, but mean and median both are same. It's a correct option. Absolute error loss. What is the meaning of the absolute error loss? You have to find the median, but in this case mean, median, mode are same, so this is also correct. Absolute error is the mean is also the correct. All are my correct options. Okay, look at this one. Xi follows the normal distribution with the mean is theta, variance is my 10. Fine. Theta is my prior, again it's follow the normal distribution with the 0, tau square is my 20. So can you write the sample mean? Sample mean is my this divided by 10 over n. What is the n is 10. That means it is theta over 1. Then the mode, because both are the normal, so the posterior is also the normal, and for the normal case mean and mode are same, so I can say this is also the mean. So can you find the mean of this? That is, we have to find the weightage average. 20 divided by 20 plus 1 of theta plus 1 over 20 plus 1 of this mean. So this part is 0. 20 divided by 21. What is the theta is? Sample mean. Xi divided by 10, and which is given to be as x bar. So what is the mean is? First option is cancelled. Second option is the correct option. Now this is my theta cap. Fine. Now look at the third option. Whenever x bar is greater than 0. So what is the meaning of that? Because 20 over 21 is my less than 1, and when x bar is greater than 0, so it means this is less than of x bar. Is the correct option. Whenever x bar is my less than 0, that's a negative. Once it's a negative, this number is less than 1, so this ratio will be my greater than of this one. So right answers are my B, C and D are my correct options. Okay, look at this another one. Xi follows my normal distribution of theta comma 1. Prior distribution is also follows the normal distribution with the mean is 2, variance is 2. So you can find the sample mean. This is my theta and 1 over n. N is my 8. So posterior is also the normal distribution. So once the posterior is normal, prior is normal, so it means prior is my conjugate prior. Fine. So can you find the mean? What is the mean? Mean is my 2 over 1 plus 8 into theta plus 1 over 8 and the weightage, it is a 2 weightage average of this. So 2 plus 1 over 8 of 2. So what is the LCM is 16 plus 1, 17 over 8 is LCM. It is 2 theta plus 1 over 4. So because I can take the LCM 8. So if I take the LCM 8, it will be 16 theta plus 2 over 17. What is the theta is? Sample mean. Xi over n. N is my 8. And which is come to be x bar. So what is that? This expression is 16 x bar plus 2 over 17 is my posterior mean. So the posterior mean is my here correct option. For the absolute error loss, what is the absolute error loss is? We are talking about the median. Okay, but it's a normal distribution, so mean, median are same, so it is also the correct option. Square loss error, that is the meaning of the mean. So for the mean, Bayes estimator is the same, so which is also the correct option. All are my correct answers. Okay, what is given to you? X condition, this follows my normal distribution with here, and theta 1, theta 2 both are my again a normal distribution with my here with my tau square. Fine. Then the posterior is also the normal. Fine. But he said it's not a normal. Cancel out. They are my IID. Fine. They are my independent. So both are independent. So definitely x1 and x2 are independent. So he said they are not independent. This option is also cancel out. Fine. Now since prior is my IID, fine, then the corresponding distribution, this is also the IID. Fine. So but he said they are not identical, this is a cancel, only left option is my here. Moreover, this is the standard result of the Bayes estimate. Okay, look at this another one. If theta is the probability of getting head, theta, that is the probability of the head is my theta, then the coin is tossed 3 times. That means is sometime follow the binomial distribution with the parameter is 3 and theta is there. Y1 if all are head, and then so on. Prior is my beta distribution, and here then theta I cap is my this when of this. Okay, so firstly we can find for here. Fine. So what is the meaning of that? I is equal to 1, that means y is equal to 1. When y is equal to 1, what is my function? Y is equal to 1, all are my head. When you toss the 3 times, what is the probability of this? PQ. What is the prior? Prior is my beta distribution. What is the formula for the beta distribution? Is x of this 1 minus x of beta minus 1. Then you can find the posterior. Find what is the posterior is, sorry, this is the theta is there, so posterior of theta. So I can multiply them, it is alpha plus 2 1 minus of this. Can you identify that distribution, which is again a beta distribution of parameter alpha plus 3, that is n plus 1 and n plus 1. Fine. Okay, then similarly for the y is equal to 2, what is my f of x? All are my tail, this is my here. Posterior, prior is my similar. Fine. So when you multiply this, what is the posterior? Posterior is theta raised to power alpha minus 1, beta will be of here, which is again follows the beta distribution with the mean alpha, and this is 1 here. Fine. Now you have to find the posterior mean. What is that? Theta 1 cap. What is the mean of the beta distribution? Alpha plus 3 over beta plus 3. Sorry, for the beta distribution it's alpha over alpha plus beta, so you have to add them. Fine. This is of this case. What is that? Theta 2 cap. This is alpha over alpha plus beta plus 3. Then which of the following is whole? Clearly says that, because denominator is always a positive. Fine. So we clearly says theta 1 cap is greater than of the theta 2 cap. Otherwise you can simply do like this way, you can subtract them and you can check it will always be greater than 0. So first option is correct, second is cancelled. Now look at the third option. What is the third option is when y is equal to 3. When y is equal to 3, that means otherwise. So that means it follows the binomial distribution with the parameter here. So what is that? It's a nc of y, theta raised to power y, 1 minus theta of 3 minus y. This is the general formula for that. Fine. So when y is equal to 3, what is that? 3c1 is here, so it is my theta cube. It will be 0. Now as what is that theta cube? It is nothing but my y is equal to 1, which is itself follows the beta distribution. So once is a beta distribution, so third option is the correct option. Is not a beta distribution is the cancel option. Right answers are A and C are the correct options. Otherwise what you can do in another manner. What is the meaning of that otherwise? It means that is not all are head, not all are tail. So your distribution will be 3c1 of 3 minus 1 and 3c2 of this case. Fine. Now if you solve this, you can see 3 theta will be common, 1 minus theta of this one. Fine. So now prior is already given to you as beta distribution. Fine. Now if you find the posterior, 3 is independent of this, so I can skip that. It is alpha and this is my beta. What is that? This is nothing but my again the beta distribution with the parameter alpha plus 1, beta plus 1. So again the C option is the correct option, D option is cancelled. Okay, look at this another one. Suppose a small clinical trial to study the effectiveness of the particular illness 10 patients are enrolled in the experiment. So 10 patients are enrolled in the experiment. Theta is the probability of the randomly chosen, that is a recover probability. Fine. This is given to you. So what is the meaning of that? It follows my binomial distribution. N is here. From the standard Bayesian analysis, consider beta is my, that's the prior distribution, beta of 0.5, 0.5. That means, what is that? This prior on the theta. So I can say this is my, how you can say, if I say this is beta distribution of alpha comma beta, then you can written as alpha minus 1 and 1 minus x of beta minus 1. So 0.5 minus 1 is minus half of minus half. Suppose 6 out of 10 are exactly covered. 6 out of 10 is exactly covered. Okay, so it means once you can find the probability distribution is nc theta, theta raised to power, sorry, ncx of this 1 minus theta. This is a binomial distribution. Fine. Now what is given to you at x is equal to 6? What is the answer of this? So it's a 10c6 theta raised to power 6 1 minus of 4, because this is a constant part. Now this is a likelihood. We can define the posterior. So what is the posterior? You can say it's a proportional. This is a constant. We can skip that. If you take this 6, 12, 11 by 6, and this is my 8 minus 1 is 7 by 2. Which distribution it follows? It follows the beta distribution. The answer will be 17 by 6 and plus 1, 9 over 2. Fine. Then you have to find the scared loss. What is the meaning of the scared loss is you have to calculate the mean. So what is the mean of the beta distribution? 17 over 6 divided by 17 over 6 plus 9 over 2. So if I take the 6 as LCM, the numerator part will be plus 27. Fine. Is this something wrong? So what is that? This is my beta distribution. This is my beta distribution. If you multiply them, it is 6 minus half, 12. Sorry, it's a 2. Sorry, it's a 2. It is my 2. It is my 2. This is my 2. Fine. So it is my, it is calculation here. So what is that? What is that? It follows my beta distribution of n plus 1. So 13 over 2 and it is 9 over 2. So what is the mean of this? Mean is 13 over 2 divided by 13 over 2 plus 9 over 2. It is a 13 by 9, 22. Fine. So if this is there, this option cancel, this option cancel. Now what is that? This is the prior, this is the posterior. So theta divided by x. Fine, because I have taken, what is the axis? Out of the 6, 6 out of the 10. So this is also the, this basically this answer is my here. So this is a simple way. Okay, now look at this one. X follows my binomial distribution with n comma p, where n is given to you. So n is known, only the p is my unknown. So if p is my unknown, then the prior will always be in the form of the p. So the p is my uniform distribution over 0 comma 1. Fine. So that's a very simple. You can find the function of this ncx p of x 1 minus p of n minus x. What is the prior is? It's a uniform distribution, so it is a 1 over 1, where it's a uniform distribution of the p. So that means p is lies from this to this, and from here n is my, p is my unknown, so probability is again lies here. Then under the scared loss error, it means you are talking about the mean. The observation at x is equal to n. So we can find at x is equal to n. What is the answer of this? This value is 1. This is my p raised to power n only. Posterior is my pi, so now you can, prior is my pi, that is 1. Now you can find the multiply, it is my p raised to power n. Then you can find the mean of this. Can you identify which distribution is here? Can I write this term as of this? Which one is there? This is nothing but my beta distribution of n plus 1 to n. So now under the scared loss error, you have to find the mean. What is the mean of this? alpha, that's the first term, divided by sum of them. So this is the right answer of this. So Bayes estimate of the P is here. This option is cancelled. Fine. Now how you can find the median? Because in the beta distribution there is no closed formula for the beta distribution. Like if X is my beta distribution with the parameter alpha beta, we all know mean is my alpha over alpha plus beta, but you are unable to write the median in terms of here. So what you can do now, your target is to find the median of posterior. Fine. So this is my p raised to power n divided by, because this is not the probability density function. So how you can make this probability density function? The answer is beta of this. So I have to divide this by distribution of here into dp. Since it's a median, I can written as a half. The denominator part is a constant, so I can written as outside. So what is that? If you remember how you can open this beta distribution of alpha comma beta. This is gamma of alpha, gamma of beta divided by here. So if I calculate this numerator part, it will be gamma of n plus 1 and gamma of n plus 2. So what is that? Gamma of n plus 1, this is n plus 1 of n plus 1, that is 1 over n plus 1. So this part will be 1 over this is outside, p raised to power n, dp is my half, 0 to m. Now what is the integration of this? N plus 1 will be cancelled out, so it is m over n plus 1 minus 0 is half. So can you find the m? M will be 2 raised to power minus of, this is the right answer. So for case of the median, you can easily find from the domain from 0 to m. Okay, look at this another one. Suppose x is given to you here. It is my 2x by theta square, and x is known to you, theta is unknown. So you can skip the constant parts. It is basically here. Prior pi is a uniform distribution over the 0, 1. So here is a 0 is less than of theta, and this is the value of this one. So I can write the function as a 1. If I multiply them, because it's based on the single observation, so the likelihood is nothing but my here. What is my posterior? You can simply say posterior is multiplication of this 1 by theta square. 0 less than x less than theta is less than 1. Fine. Now do you get that is any of the distribution is here? It is not an easy identify that. It is, remember, it is not a beta distribution. You may write like of this, but beta distribution is applicable only when this number will be my greater than of 0. But if you write this as a beta distribution, it will be my minus 1. Fine. So it is not the beta distribution. Now what will happen? This is the second category. What will happen if you are unable to identify the distribution? Then how you can find the Bayes estimator? This is my mean. Fine. This is my absolute means, that is a median. Fine. How you can find the mean? That's again a very simple. What you can do is, you can theta times of this divided by a simple of this. Fine. Because the numerator part is my theta, that's mean, and divided by the sample space. What is the range of the theta is? X to 1. It is x to 1. That's the answer. Now it is a 1 over theta, that's a log of theta over the domain 1 to x. The integration of this will be minus 1 over theta from 1 to x. The numerator is log 1 is 0 minus log x. The denominator part will be minus 1 plus 1 over x. So if I take the LCM, it is minus x log of x divided by 1 minus x. So you can see this is the right answer. This option is cancelled. Fine. Is there any doubt up to here? Now, how you can find the median? Again, the same rule. Instead of the multiply by theta, we can simply take off this from the lower limit is my x to the median divided by 1 by theta. Because we have to talk about the median, so denominator is a complete range, that is x to 1. This is must be equal to half for the median. So now you can see the denominator part will be, I can take the numerator is minus 1 over theta from x to m, and the denominator part I already computed here, minus 1 plus 1 over x. So what is that? It is minus 1 over m minus plus 1 over x. It will be minus 1 over 2 plus 1 over 2x. So I can take 1 by 2 here. So what will happen? It will be my 1 by x. So this implies minus 1 over 2 is minus half minus here. Fine, it is 1 over 2x minus 1 over x. If you take 2x is LCM, 1 minus 2 is minus here. Now you can take minus, will be cancelled out. So if you take the LCM, it will be 2x over 1 plus x. So forget about the plus minus sign because this is the independent of theta. So this is the right answer, this is wrong answer. So this approach you can apply only when you are unable to identify the distribution. If you are able to identify the distribution, then there is a very simple, you can write the as I discussed earlier. Okay, look at this another one. What is given to you? Xi's are my normal distribution. Fine, Xi's are my normal distribution with here. Prior is my uniform distribution. Now you can see here, if this is also the normal distribution, then we can say the posterior is a normal distribution, and then we can apply the earlier formula. That's a weightage average, but it is not true here. So what you can do, again a very simple, there is no need to think much about that. You can simply look about here. Firstly, can you write this as the PDF of this is my this over the domain of this. Now you have to find the x3. What is the x3? This is nothing but my ordered statistics. Fine. So what is the kind of the ordered statistics? That's a maximum ordered statistics because we have the 3 samples and it's a maximum 3. So what is the PDF of x3? So you all know the PDF of the xn is fx into it is 1 minus, it is n minus 1 of fx. Fine. So from here, can you find the PDF of this? It is 1 over theta. Fine. What is the CDF of x? It is my x minus 0 over this. Now if I substitute, n is my 3, this is my x over theta raised to power n minus 1, this is my here. So it is 3x square over cube. Now since the prior is dependent upon the theta only, because x is known to you, so I can simply take the one parameter which is as 1 over theta cube. Fine, because rest of the 3x square is a constant number. Now the prior is my here, so you can find the posterior. So if you multiply this one by here, it is my this case. The domain is, what is that? This is my 0 less than x less than theta less than 1. Now you can see this is similar to the previous one. Instead of the theta square, it is my here. Then you have to find the Bayesian estimator because you are unable to identify the distribution. So what I can do, I can simply find the mean divided by this. Fine. So the mean will be x to 1 and it is from x to 1. And you can see whenever you can do, you always get the finite answer. Fine. So you can see what is that? It's a 1 over theta square. So it is minus 1 over theta from 1 to x, and it is minus 1 over 2 theta square. Fine. From 1 to x. Now clearly say the answer will be in terms of the x square. So which is none of them. So your answer will be here. Otherwise I can solve for you. This will be minus 1 plus 1 over x divided by 1 over 2 I can take as outside, minus 1 plus 1 over x square. So the numerator part will be 1 minus x over x, denominator part will be 1 minus x square over x square. Now you can see 1x will be cancelled, 1x minus 1 will be cancelled. So it's a 2x over 1 plus x is the right answer. So you can see this is not the Bayes estimator because it's a 1 over x. It is not there, it is not there. So it is a unique is the right answer. Okay, look at this another one. X is a sample of the Poisson distribution with the parameter lambda. This over lambda raised to power x divided by x. What is that? This is basically a parameter of here. This is basically here. lambda is my prior distribution, fine. So which is written, because it's a variable, we have to return in terms of the z, fine. Now you can find the posterior, you can multiply them, because this is independent of the lambda, so you can skip this here. It is my here into this. Can you identify the distribution? Yes, you can easily identify the distribution. This is a gamma distribution with the parameter x plus 1 and of 2, fine. So once you can find that, can you find under the square laws? What is the square laws is? You have to find the mean. So what is the mean of the gamma distribution? The first parameter divided by second parameter. So the mean of this is my here. The posterior distribution is a gamma. Yes, it's a gamma. Also correct. The Bayes estimator of e raised to power lambda. But this is the estimator of lambda. How you can do? That's again a simple. You have to find this. So this multiply by here into, fine, divided by the gamma of this, fine. Or otherwise this is a constant value, because it is independent of lambda, there is no need of them. So can you say, again you can see which is equivalent to the e raised to power minus of, again it is a gamma distribution. The mean is, parameter is here. So can you find the mean? Is it a mean is here? No, because the mean is x plus 1 over 1. So this option is cancelled. Similarly, I can see, I can find the, I can return like of this. So because the gamma, if I write here e raised to power 2 lambda of this, so basically I have to multiply this by here. So what is that? This is, again I can return this in terms of here, so which is again a gamma distribution with the parameter of here. So you can see this is not of this one. So which is a B and C are the right answer. X is a exponential distribution with the mean is 1 by lambda. It means X follows exponential distribution with the parameter here. So what is the given information? It is here, fine. The parameter lambda is the prior, which is given to be here. So which is nothing but this into, now sample size is 1. So we can find the posterior, fine. So I can multiply them. So posterior will be lambda square e raised to power of this, fine. What is the distribution is? Again a gamma distribution with the parameter 3 and 1 plus x. But right now we are talking about this is, so therefore if I found the Bayesian estimates of lambda, so it will be mean of this, fine. But here they are talking about this 1 over lambda. So remember that 1 over lambda is not equal to the base of this. This is not true. So how you can find? There are the two methods, fine. The first method, as I told you, you can multiply this posterior by the parameter. So if you multiply them, it will be my here, fine. And then you can integrate them. So what is the integration of this parameter lambda is? From 0 to infinity divided by the gamma function of 3, 1 plus x. So you can see the numerator part is again a gamma distribution, fine. What is the numerator part is a gamma distribution with the parameter 2, 1 plus x divided by gamma of 3 of 1 plus x, fine. And if you solve them, you can clearly say this is nothing but my, how you can solve that? How you can open this gamma of a comma b? You are unable to open that. How you can open this gamma of 2, 3? It is not possible. Yes, it is not possible. You can open them. So I can apply this second method. What is the second method is? That's quite easy, because I can simply take y is equal to 1 over lambda, fine. So can I find the value of lambda from here? It's a 1 over y. So I can express the given function prior and posterior in terms of the y. So what is that? Firstly here, this will be my 1 over y e raised to power minus x over y, fine. Prior will be my 1 over y e raised to power minus 1 over y. Posterior will be 1 over y square e raised to power minus lambda is my 1 over y of 1 plus x. Now do you get any of the distribution is here, this is nothing but my inverse gamma distribution. Fine. So once you know this is the inverse gamma distribution, can you know the distribution of this? What is that gamma inverse distribution? I can written this as y of minus of 2 e raised to power minus 1 over y of 1 plus x. So can you find the distribution of this? It is minus 3, the same thing of here. Fine. Now how you can find the mean of the, you can see the PDF of the inverse gamma distribution is here, and e raised to power minus beta over x. This follows my inverse gamma distribution with the parameter. If I consider this is my minus 1, then it is minus alpha and beta. And for the inverse gamma distribution, we all know the mean will be beta over alpha minus 1. So you can see what is the value of the alpha. You can see it's a minus 2. So I can written this as, sorry, it is definitely n plus 1. It is my minus 1. Fine. Now you can see what is the mean of this, beta over alpha minus 1. So alpha is here, minus 1 is minus of 2. So x plus 1 over, because constant doesn't matter, minus 2 plus 2 doesn't matter. So the right answer is my here. Here I am unable to write this in terms of the gamma. How you can open this? If you remember what is the formula for the gamma of alpha comma beta, how you can open that? I know that beta of alpha comma beta, I can written this as gamma in terms of the gamma function. But how we can open that, you can think about that. Otherwise there is no need, you can integrate the numerator part. How I can write this is lambda square e raised to power of this. You can integrate this numerator part. You can integrate the numerator, you can integrate the denominator, again you will get this as the right answer. Okay, look at this another one. X follows my Poisson distribution. So e raised to power minus lambda over x factorial. Exponential distribution with the mean 4. So this follows the exponential distribution with the 4. So basically this is 4 e raised to power 4 of this. Find the posterior. What is the posterior? If you multiply them, 4 is a constant, x is a constant. So it is lambda raised to power x e raised to power minus 5 of this. If the observed value of the x is 0, so at x is equal to 0, what is my posterior? At x is 0, it is my e raised to power of this. What is that? This is my exponential distribution with the parameter 5. Then which of the following is the confidence interval? Very simple. You can start from here. Fine. It comes to be 0.95, where c is my. Okay, so I can return, because it's exponential distribution, so I can return in terms of the CDF. What is the CDF of the exponential distribution of the exponential? E raised to power 5x. So if I start from here, it is 1 minus 5c, 1 minus e raised to power 0. So it's a 1, it's a cancel out, it's a 1 minus e raised to power 5c. If I take c is equal to 0.95, does it comes in 0.95? No. First option is cancel. Look at the second option. When I take here, fine, if I take c is equal to 20 by 5. So if I take c as a 20 by 5 here, so what will happen? 1 minus 5 into log of 20 divided by 5. 5 will be cancelled out. 1 minus e of 1 by 20. You can see it's a 0.95. So this option is a correct option. Look at the third options. You have to write this probability. C is less than lambda is less than of e raised to power c. I written in terms of the CDF, which is of here. I can written this as e raised to power minus 5 e raised to power c minus 1 plus e raised to power minus 5c. Fine. Now if c is equal to this, if I substitute here, is e raised to power 5 e raised to power log 20 divided by 5 plus e raised to power minus log of 20. Clearly says that it is not 0.95, because this number plus this number will not be a 0.95. Similarly, you can check this one. This option is also cancelled. Right option is only B is the correct answer. Okay. Now this is the next category. This is the next category, which is called as the Bayes classifier. Fine. Recently, in the recent year, these Bayes classifier questions are asking. So what is a Bayes classifier? First of all, the concept of the Bayes classifier is you have to classify the classes. Firstly, there are the two classes. One is the omega 1, second is omega 2. Firstly, check whether the class is given to you. You can see that the class is given to you. Okay, so what is the omega 1 is? Omega 1 is belongs to the less than of half, but lower limit is 0. So it is 0 to half, and this is my half to 1. If the class is not given to you, then how we can find that will be seen in the next question. If pi 1 and pi 2 are my prior probabilities, then which of the following is there? Whenever there is a Bayes classifier question, you always find the firstly average probability. What is the average probability? Is average misclassification probability. That is capital P of F1 over the class 2 plus 1 minus P class of F2 over this. What is the meaning of that? This is the class 1 probability. This is the class 2 probability. And this average probability is always with the maximum one. So you can see P, this is a prior probability, that's a pi 1 and pi 2. So if I consider this is my P, what is F1? 1. I can integrate over this gamma 2. So what is the integration of 1 over the domain half? This is 1 minus P. F2, F2 is my 2x over the gamma 1. Gamma 1 is my 0 to half. So what is that? It is my 1 minus half is half. This is 1 minus P. It is my x here. It's 1 by 4. So you can see 4 will be LCM. So it's 1 plus P over 4. This is my misclassification probability, and it is always with a maximum. But you can see in the last option there is a pi 1 and pi 2. Basically P is my pi 1. This is my pi 1. This number is my pi 2. So what will happen if pi 1 is equal to pi 2 are same? It means they are half. Fine. That is P is my half. So if I substitute P is here, you will get answer as 3 by 8. So this is the right answer. And once it's a maximum probability, then we call as a Bayes classifier. Otherwise not. Fine. Now look at that first part. If pi 1 and pi 2 are same, it means they are half. If I substitute here, again it's a pi is a Bayes classifier. When pi 1 and pi 2, when pi 1 is greater than pi 2, it means pi 1 basically P is my here. Fine. So when pi 1 is my greater than pi 2, it means the probability is not equal to 3 by 8, then it means it is not a Bayes classifier. Again, when pi 1 is less than of the pi 2, then again it is not a classifier. So the right answer is my A and D. Fine. Okay. Now the question arises is how you can find these classes. Fine. Let me tell you. Otherwise the next question will be here, but I will tell you at here in this example. You can draw the graph of this. You can draw the graph of this on the same one. 0 to 1. The graph is here. Fine. Then on the 0 to 1 the graph will be 2x. So this point will be my, if I take y is equal to 2x, so this will be my here. Fine. The coordinate of this will be my x. Y is equal to 1. X will be my half. Fine. Now how you can define the class 1? You have to consider all those x. I can written like here. You can consider all those x such that f1 of x is greater than of f2 x, while the class 2 is collection of all those x such that f1 x is less than or equal to f2 x. Fine. Now you can see the graphically, this point is my half. When I consider from 0 to half, this is my f2, this is my f1. When I consider 0 to half, you can see this value is always be greater than of this. It means this x is my 0 comma half, because equality is not there. So it means this point is not belongs to this. You can see the class 1 is my 0 to half. While when you take x from 1 to 2, this value is higher than of the f1. So this value will be half comma 1. This is the way you can classify the classes. If somebody asks you find the probability of this class, how you can find the probability of the class 1, which is nothing but f1 over the domain of 2. What is the probability of the class 2, which is nothing but f2 class of f1. And what is the average probability? You can find the weighted average of this. So if pi 1 is my prior probability of the class 1, then I can multiply this by here plus pi 2 over the class of second. Fine. Such that because they are the probabilities, so this sum will always be a 1. This is the Bayes classified theory. Okay, look at this another one. Again, you can see it's a classification problem and they are nothing given you about the classes. You can firstly draw the graph. Fine. 0 to 1, the value is my 1. f2, 1 plus something. So 1 plus of this, it means, what is the meaning of that? So we can firstly found collection of all those x such that f1 is greater than of the f2. If you draw the graphically, that's very good. If you are unable to do the graphically, then we can start from here. What is the f1 is? 1 is greater than of 1 plus cos 2 pi x. What is the meaning of that? Cos of 2 pi x must be less than 0. So in which quadrant it lies? Cos will be negative when x varies from pi by 2 to 3 pi by 2. So it means the x belongs to 1 over 4 comma 3 over 4. Fine. So that means your class 1 is my 1 over 4 comma 3 over 4. So the Bayesian classification for the class 1 is my correct option. Fine. Randomly chosen. Now you have to find the probability of the misclassified. What is the probability of the misclassified? f1 over the class 1, that is over the gamma 2, but we are unable to find the gamma 2 firstly. Okay, find the probability of the gamma of the class 2. What is the probability of the class 2 is f2 over the gamma 1. Fine. So I can find it easily. So look at that. If I clear this screen, fine. So I can, what is the f1? f2 over the gamma 1. What is f2? 1 plus cos. What is the integration of the 1 plus cos is x plus sine 2 pi x divided by 2 pi. Domain is my gamma 1. 1 by 4 to 3 by 4. So what is the answer of this? When you substitute 3 by 4 minus plus, it's a 3 by 4. So it's a 3 by 2. 3 by 2 is my minus 1 over 2 pi. Minus when you substitute 1 by 4, it is my pi, it's a 1 over 2 pi. So what is the answer of this? Is my 2 by 4 is a 1 over 2. It is my minus 2 over 2 pi. So it's a 1 over pi. So can you take the LCM? It's a pi minus 2 over 2 pi. This is the probability of the misclassified for the class 2. You can see this is also the right answer. Now for finding the class 1, you have to find this omega 2, that is a class 2. How you can find the class 2? Such that f1 will be less than or equal to f2. So f1 is 1, is a 1 plus cos 2 pi x. So that means cos of 2 pi x must be greater than or equal to 0. So in which quadrant it will be positive? So this is positive when x lies in the first quadrant or x lies in the fourth quadrant. So what is the fourth quadrant is? 3 pi by 2 to 2 pi. So from here you can find the value of the x is my 0 to 1 by 4, and from here you can find the value of the x as 3 by 4 to 1. Fine. So therefore your gamma 2 will be, I can written here, gamma 2 is my 0 comma 1 by 4 union 3 by 4 comma 1. Fine. Then how you can find the misclassification probability for this? It's a f1 over the domain gamma 2. What is the f1 is? 1. So basically this part is broken from 0 to 1 by 4 interval plus 3 by 4 to 1 interval. So now can you find the probability? If you integrate from 0 to 1 by 4, answer is 1 by 4. If you integrate from this, answer is 1 by 4. The answer is 1 by 2. So you can see its answer is 1 by. Fine. Now the last part will be, what is the last part is, you have to find the average misclassification probability. So this is the classification 2, this is the classification here. So what is that? It's a pi 1 of 1 over 2, this is a class 1, plus pi 2 class of this. This is my average misclassification probability. Always remember, the average misclassification probability is always with a maximum one. Now what is the pi 1 and pi 2? So pi 1 and pi 2 are the prior probabilities, are equal. So what is the meaning of that? When pi 1 and pi 2 are same, it means they are half. So what is that? If you substitute here, it is 1 by 4. It is my pi minus 2 over 4 pi. So I can take the 4 pi as the LCM. It is pi plus pi is a 2 pi minus of 2. Pi minus 1 over 2 pi is the right answer. You can see here. So all are my 4 are the correct options for this example. Okay, look at this another one. Consider a classified probability. F1 you can define is a uniform distribution over the domain here. F2 you can define as 1 over 4 from 1 to 4. Pi is the prior probability of this 0 to 2. If I consider the 0, 1, then and the base risk is nothing but the average misclassification probability. Firstly, we can try to find the omega 1. Can you draw the graph? 0 to 1, answer will be my 1. This is my F1. 1 to 5, its answer is my 1 by 4. 1 by 4 will be here. Fine. Now clearly says F1 is always be greater than of the F2. So it means F1 is always be greater than of the F2. So what is the class of 1? This is nothing but my 0 to 1, because it after that, what is the answer of this? It will be the 0. What is that? It will be 0 elsewhere. Fine. Similarly, it's a 0 elsewhere. And in this class from 1 to 5, what is that? From this is my F1. From 1 to 5, F1 is my less than or F2. So it is from my here. Fine. You can easily classify them. Then these are talking about the average misclassification probability. So we can firstly find the class 1 probability. What is that? Integration of the F1 over the domain gamma 2. F1 is my 1. F2 gamma 2 is 1 to 5. What is the integration of this? Is 4. Fine. What is the class 2? That is over the gamma 1 from, sorry, it's wrong. Because probability can't be greater than 1. It means something is wrong. That's why it's wrong, because there is no value of the gamma 2. Gamma 2 is 5, because in this 1 to 5 there is no F1 is defined. So gamma 2 is my 5, so it means it is my 5 of 1. Answer is my 0. In this case it is my 1 by 4. Domain is my 0 to 1. So answer is my 1 by 4. So what is the average misclassification probability? Pi 1 of the class 1 plus pi 2 of class 1 by 4. So it is my pi 2 by 4 is the misclassification probability. Now if pi is my less than 1 by 3, pi is my prior probability of 0, 2. 0, 2 lies in the F1. Fine. So that means pi 1 is my less than 1 by 3. So what will be my pi 2? Sorry, we can't say that. If I consider this is the equality case, if pi 1 is my 1 by 3, what is my pi 2? Pi 2 is my 2 over 3. If I substitute here, it will be my 2 over, that is my 1 over 6. This is my base risk. Base risk is the average. So this is my average misclassification. So it means this is my right answer. Fine. Now since it is always with a maximum probability, fine. Now whenever the value of this is less than 1, whatever the value, whether the pi 1 is less than 1 over 3 or greater than 1 over 3, whatever you can find the probability of misclassification, that is always be less than of 1 by 6 because this is the maximum one. He said when pi is less than 1 by 3 it is smaller than, correct option. When it is a greater than 1 it is smaller than of the maximum, again the correct option. For all the values of the pi the classification is unique, is not right answer. Why? Because you can take the different classifier but the maximum probability will be 1 by 6. Okay, look at this another one. Again function is given to you, you can find the likelihood firstly, lambda raised to power n e raised to power lambda of here, fine. Prior is given to you, you can find the posterior easily. What is the posterior? If you multiply them, 9 is a constant, so this is n plus 1 e raised to power of this, fine. What is that? It follows the gamma distribution with n plus 2 and summation of xi plus 3, fine. Now your target is to find the probability. They are not talking about the mean or the median, they are talking about the probability. Again a very simple tool. Firstly x1 is my here, this is my exponential distribution. So firstly I can find this probability in terms of the CDF. What is the CDF of this? E raised to power lambda of x. Otherwise you can integrate from 1 to 2 of this part, fine. So if you solve them it will be 1 minus e raised to power 2 lambda minus plus e raised to power 1 lambda. So e raised to power minus of this, fine. Now how you can find this probability? This expression will be, this is my probability into the likelihood. What is the likelihood? This is my likelihood into e raised to power here summation of xi plus of 3. What is the lambda domain is? 0 to infinity. So it's very easy, there is no need to solve this integration. If you open them, the first part will be my n plus 1 e raised to power lambda, again common, xi plus 4, fine, minus lambda of n plus 1 e raised to power summation xi plus 5. Now if you look about 0 to infinity, what is that? It's a gamma distribution, fine. So once you take this as a gamma distribution, it will be gamma of n plus 2 and of this expression. This will be again n plus 2 of xi plus 5, fine. Then what is that? If you divide it by the gamma of this, what is that? You can check any of the expression which involve this power n plus 2 and this of n plus 2. Is there any term which involve here? You can see this is the right answer of this problem. Otherwise once you can integrate them, divided by what is the posterior is here, you can see this is gamma of n plus 2 over this. Similarly for this, divided by gamma of n plus 2 of gamma of this. So the better is that there is, because in each of this case numerator is a fix, only the difference in the denominator, and the power is, we have calculated the power is n plus 2. So the right answer is my C is the right answer. Okay, look at this one. Xi's are my normal distribution, theta is my Cauchy distribution, where sigma is my norm, fine. So Xi's here, if it is a known I can consider as a 1. Theta is my unknown, is a prior, where mu and tau are known. So I can consider a very simple case here. This is a Cauchy standard distribution, 1 over pi 1 plus theta square of inverse, fine. Then the posterior distribution of this, that's very simple. You can see if I consider as Xi's here, Cauchy distribution is this. Can you find the likelihood of this with respect to n, which comes to be here? Then you can multiply this by this, that is a L into posterior. This is my posterior, but you can see there is no relation between them. Then how you can find that? We can divide it by their mean. That is my, this is called as marginal. So I can return like of this, where m is my marginal, fine. Then how you can find this? Now this is the distribution. How you can find the mean? Theta times of here, this is my posterior. If I call this as a posterior, now you can see it is not an easy target to integrate them. So this is a standard result you must remember. Once is there, the posterior mean will be the theta star, variance is my sigma square. What is the variance and the mean? theta star is my MLE, sigma square is my variance of this. So since there is no need to solve because they are talking about whether they are existence or not. So you can see theta star is MLE, which existence, variance is there, which is also existence. So the posterior mean does not exist, cancel out. Posterior mean exists, variance is infinite, cancel. Posterior mean exists, variance is finite, true. Variance finite but mean does not exist, cancel out. C is my right answer of this problem. Okay, look at this another one. X is follows my normal distribution with unknown mean, variance is 1. The prior is mu. Consider the problem of this, which are the form. Okay, prior is not given to you. Prior is not given to you. Okay, then the Bayes estimator of mu under the proper prior. What is the meaning of the proper prior? If you integrate this, it must be 1. If it is infinite, then we call as the improper. The Bayes estimator for the proper prior. So you can consider any of the proper prior. Okay, you can think any of this, like say uniform distribution 1, or you can consider the normal distribution, say 0, 1. Normal distribution is we can consider the any PDF, any prior PDF whose integration is 1. I can consider the normal distribution. Once both are normal, you all know the posterior is also normal. You can find the mean of the posterior and the variance of the posterior. So it means the mean Bayes estimator under the squared laws. What is the meaning of the squared laws is you are talking about the mean. So under the mean, can you find the mean of when both are normal? Yes, this is the right answer. If I consider the below one, if there is an improper prior, that means you can think about any of that distribution whose integration is infinite. Thus the Bayes estimator is infinite, that's the meaning of this. There is a proper prior, that means there exists a proper prior whose Bayes estimator is unbiased. That is not true. Okay, we will see that. Bayes estimator of this end here. Okay, look at this case. As I told you the simple shortcut trick, whenever you consider the improper bias, there is still a Bayes estimator is finite. So what is the meaning of that? Look at that. There is the improper prior, Bayes estimator is unbiased. You can see that is a finite and unbiased. So it means this option is also correct. Fine. Now I can give you the counter examples for these cases are. If I consider X is my binomial distribution, beta is my here. So this, if I consider A and B are 0, so my pi this. Now can you think about this? If you integrate them, 1 over P, 1 minus P. What is the P is my 0 to 1. So can you see what is that? Is it integration is 1? No. Why? Because if you take this as a partial fraction like of this, what is the integration of this from 0 to 1? This is my divergent series. This is my divergent series. So the answer is infinite. So once it's infinite, it means it's a improper prior. Fine. So that's a improper. But you can see that the estimator of P, you can easily find that what is the binomial estimator? That's a sum divided by n. It means once the prior has improper, and we all know the sample mean is my always be the unbiased. Fine. Second case, once you have find the posterior from here, and this is the binomial NCX P raised to power x 1 minus P raised to power n minus x. So if I multiply them, fine. So you will get as posterior this. Then again clearly says that this is the posterior probability only when you take as here. Why? If you consider x is my 0, this value becomes my minus 1, this value becomes my n minus 1. Again this becomes my divergent. So it is improper. So therefore you can see x equal to 0 and x equal to n is my improper problem. So it means the right answer of this is my here. This is the right answer. When you have the proper, this unbiased is a wrong, this is a wrong. Right answer is my A and D are the correct answers. Okay, look at the last question. So if x is given to you a binomial distribution, so it is my NCX probability of x 1 minus P of n minus x, where P is my known. Now P is known, n is my unknown. N is my prior distribution, is a Poisson distribution. So e raised to power minus lambda, this over n divided by n factorial, because you can see this is my Poisson distribution, but this Poisson distribution is for the x, so this n is my, then you can find the sample size is my 1, so you can find the posterior. What is the posterior is ncx p, because p, okay, p raised to power x 1 minus p of n minus x e raised to power minus lambda here. So you can see how many unknown parameter. P is my known, so there is no need to write this expression, okay, and x is my known, fine. So you can see n is my unknown, I can return this value, I can return this number as of this, x is my known, I can skip that, this over n factorial, fine. This is proportion. Now the posterior is also the Poisson distribution. Can you say, you can see ncx also, so I can return this ncx is 1 over x factorial n minus x factorial 1 minus p of n. This is also independent of n, I can skip that. Again you can see x factorial is independent, I can skip that. So it is 1 minus p of n into n minus x factorial, fine. Now I can multiply and divide it by this term, fine, and I can simply say lambda raised power x also. So what is that? This, what is that? E, I can return this quantity as lambda times this of x into 1 minus p of n minus x into n minus x factorial. Then what is that? It's a Poisson distribution, but if I multiply this by lambda also, if I multiply lambda and divide it by here, what is that? It is my Poisson distribution with the mean is lambda times 1 minus p. So it is a Poisson distribution, yes, but the mean is different from lambda, is a correct option. Second is, if x is equal to 0, where is my posterior is? This is my posterior. I can substitute x is my 0. What will happen? nc0 is my 1, p raised to power x is 1, it's a 1 minus p of n, e raised to power minus lambda, n factorial is my here, fine. Now what is that? Again clearly says that it is my Poisson distribution. How? You can see this is n over n factorial. If I return this value as e raised to power minus lambda, sorry, what is the Poisson distribution is e raised to power here, and I can multiply this, fine, and then e raised to power of this one. So what is that? E raised to power minus lambda, lambda raised to power n over n factorial. What is that? This is my Poisson distribution. I can compare them, I can merge them. It will be a Poisson distribution with the mean is of here, fine. So it means this option is also correct. How you can find the base? Has a Bayes. What is the meaning of the Bayes? You can find the mean of this minus, you have to find the n, whatever the mean you can find, that is by using the summation part of this, subtract from the n, you can check whether this is the right answer or not, and you can check for the C and D whether it's the right answer or not. This is the right answer, this is not, you can verify it and let me know your answer in the comment. So we will see the next lecture on the testing of the hypothesis, again with the help of the shortcut tricks. Till then you can simply like, share and comment on my videos. Best of luck students. Happy learning.